Today's video notes are on the average rate of change. In your notes, this should be page 6. So you are on page 6 in your note packet. The learning target is I can calculate the average rate of change for any function in an interval. So we're going to talk about what the average rate of change is. So definitions. What is the average rate of change? Right here, this is the mathematical definition. This is what you would find in the textbook as a definition for the average rate of change. F of B minus F of A all over B minus A. Now, this actually looks very similar to a formula that we know and that we've been working with. If you thought about this, awesome. If you didn't, let me remind you. This looks like our slope formula, the change in y over the change in x. F of b and minus f of a, that is the change in y values, all over b minus a, that is the change of our input values, which in our case is x. So this and this are actually equivalent formulas. This is just a fancy name, the average rate of change versus the slope. The average rate of change, though, you get to use with any kind of function, whereas a slope is only found in straight lines that you can create with a ruler and things like that. So let's talk about how we use the average rate of change. So the average rate of change is also called the slope of the secant line between 2 points. The secant line is a line that connects 2 points of any given graph, so any curve. You could create a secant line, you find the slope of that line, that is your average rate of change. We're going to take a look at a picture here so that you can better see what's going on and what I mean. So we're right now looking at the function f of x equals x squared. I want to find the average rate of change between the x value 1 and the x value 2. This is written like this, so x is between 1 and it's also between 2. This is how you write that. Alright, so here is my parabola y equals x squared. I want to find the average rate of change between the x value 1 and the x value 2. What I'm going to do is I'm going to first draw a point here, and then I'm going to draw a point here, and then I'm going to find the slope between those 2 points, and that's going to be my average rate of change. Point there, point here, because that is between x is 1 and x is 2 on my graph. Let me draw my line. So this red line that I just drew, this is my secant line. When I find the slope of this red line right here, that's going to be the average rate of change of this parabola between x equals 1 and x equals 2, my average rate of change. So let's go ahead and do some math and find out the average rate of change here. Here is the average rate of change formula, but like I said, it's basically the same thing as your slope formula. Once you have your 2 points, you're just going to plug into your slope formula. You'll have your average rate of change. So how did I just find these 2 points? Well, I just looked on a graph, obviously. So I just went from x equals 1, right here, it's 1, 1. Over here at x equals 2, it's 2, 4. That's how I just got those 2 points. Great. So I color-coded my x value as red and my y values as purple. Usually I also tell you guys that you should label your points so that you don't get mixed up. So my first point I'm going to call x1, y1. Second coordinates is x2, y2. Now, to find the average rate of change, right now what I'm going to do is answer this question of this parabola between the point x equals 1 and x equals 2. I'm just going to substitute into my slope formula because like I said, that is my average rate of change. Go ahead, so y2 minus y1 all over x2 minus x1. There is my substitution. It's nice because we don't have a lot of negatives. So it's going to be 3 all over 1, which is just equal to 3. I put m equals 3. That is the slope of the red line, but that also answers the question, what is the average rate of change of this parabola, f of x equals x squared, between 1 and 2. Basically, you're done. The average rate of change is basically calculating the slope, given that you're using the graph properly. Now, let's move on to some more examples. Alright, so let's say I give you this function as an example 1. And I'm asking you evaluate this. So right now, I'm not asking you to find an average rate of change. I just want you to substitute your function and evaluate so that you're used to seeing equations that look like this. So f of 4 and f of 3, we're going to subtract them and then we're going to do 4 minus 3. So f of 4 means I'm going to plug in 4 into my function. I'm going to get 4 squared times 2 plus 1. And then minus f of 3, I'm going to plug in 3 into my function. 3 squared is 9 times 2, 18 plus 1. We're going to find out what that is. This is what you should get when you plug in 4 into your function. And then when you plug in 3 into your function, you should get 19. That's all you're doing here. So right now, in your task, I'll be giving you this, and I'm going to give you a function, and I want you to substitute those values and to find out what the value is. I get 14 over 1, which is just 14. Great, that is example 1. Example 2. So let's say I give you another function that looks like this. You notice there's 2 x's, therefore we might need to substitute twice. So I'm asking you to evaluate this expression right here. So f of 0 minus f of 1 all over 0 minus 1. You notice this is the average rate of change. I'm just already giving you the formula and I just want you to substitute. So f of 0, 0 squared is 0 plus 0 is going to give me 0 right here minus f of 1. I'm going to plug in 1. So 1 squared, 1 times 1 is 1 plus 1 is going to give me 2. So I got 0 for this one, and for f of 1 I got 2. And then don't forget to bring down that minus sign. Great, so 0 minus 2 is just negative 2. 0 minus 1 is just negative 1. Now you should remember that negative divided by negative gives me a positive number. 2 divided by positive 1 is just 2. And you're done with example 2. So example 1 and example 2, I'm asking you to evaluate an expression given a function. So like, do you know what f of 0 means? Do you know what f of 1 means? Do you know how to substitute? And so forth. Now let's move on to the average rate of change kind of problems where you actually got to calculate the slope yourselves. Alright, so finding the average rate of change given 2 inputs. Alright, here's my slope formula just to remind me. Again, as I mentioned, this is the same thing as average rate of change, so that's why I'm putting this here. Alright, so let's say I give you a function, f of x equals x squared minus 2, and I'm asking you to find the average rate of change between the points 0 and 3. Again, this is written like this. Alright, so step 1. I need to find, so I know 0 and 3, so I know my x changes in x's right here. It's, this is my x2, this is my x1. I'm hoping if I put that in order. And then I just need to find what my y's are. So what are my y's? So here we go. How did I get these y values? Negative 2 and 7. So here's what I did. So I know that we started x equals 0. So all I did is I plugged in 0 into this function. 0 squared is 0 minus 2. 0 minus 2 gave me negative 2. So I created my first coordinate point. So this is what you're doing. You're creating your coordinate points given these x values. Alright, the next value is 3. What I did is I substituted 3 into my function. I got 3 squared, that's 9, minus 2 gives me my second coordinate point as 7. So 3, 7 right here. So you notice I created my 2 coordinate points to calculate my slope given these x values by substituting to find my y's. So that's what I did, and this is what you will be doing in the task. Alright, my next step is I usually label my points as x1, y1, x2, y2. Now, to find the average rate of change, we are basically finding the slope. So good, I'm going to create this, so find my slope, substitute. When you are substitute, you must be careful that you are preserving your signs. And remember, negative next to a negative, so the double negative always becomes a positive. So right here we're going to have 7 plus 2. 3 minus 0 is just 3. So we get 9 divided by 3. The answer is 3. So the average rate of change, and right here this is an x squared, so this right here is a parabola. This is a parabola, and we're finding what is the average rate of change between the x value of 0 and 3. So on average, it's changing by 3 units over the interval. So this is not a line, but we're finding the slope of the average rate. Basically the slope of the secant line if we want to be precise. All right, let's go on to example 4. So example 4 is very similar to example 3. Let's just repeat what we just done just to get fluid into this. So I put finding rate of change of functions you don't recognize. So let's say you have f of x equals 1 over 2x. So I know that you have not worked with functions that look like this. It's a rational function. I know you guys last year worked on quadratics, maybe some lines, things like that. So let's get some exposure of functions that you don't recognize, and let's go ahead and find the average rate of change. Here I'm given between the point x equals 1 and x equals 3. Again, step 1. I usually want to recognize what do I need to find the average rate of change. Step 1 is I need my formula. Oh, well, where is it? It's not popping up, so let's just pretend I didn't do that. But just imagine I just popped up my m equals y2 minus y1 all over x2 minus x1. So basically I'm finding the average rate of change on average between x equals 1 and x equals 3 of this function. By the way, in our later lecture, we're going to take a look at how these graphs look like when I'm graphing and what exactly are we finding. So those secant lines we're going to talk about in our next lecture. So imagine I got my slope formula. Great. So I'm going to create my coordinate points now. So step 2 is create your coordinate points after you notice what formula you need. All right, so my coordinate points, so first coordinate, so x equals 1. I'm going to substitute 1 right here. 1 all over 2 times 1. 2 times 1 is just 2, so we get 1/2 for my first 1 comma 1/2 for my first coordinate point. The next one, I'm going to substitute 3 right here. I know 2 times 3 is 6, but don't forget it's 1 over 6 for my second one. So this is how that looks like. I just did some mental math. If you need to write this down, you want to go ahead and write that down. But I created my 2 coordinate points. The blue right here comes from here. The 1 and 3 come right there. These red values right here come from after I substituted in these x values to get my y's. This is where I got these points. Now let's go ahead and find the average rate of change, which is the slope between these 2 points right here. So you notice they have fractions. Oh, and now I'm going to substitute. Great, here's my slope formula. You notice you have fractions, and again, that's why we had our fraction review, so that you know how to work with these fractions. And you should know how to do this. Great, so we substitute. So y2 is 1/6 minus y1, which is 1/2, all over x2, which is 3 minus 1. Good, so now this is easy after we combine these fractions. So let's go ahead and do that. We need a common denominator. In order to get a common denominator, I did my shortcut. In order to have this fraction right here look like, have a denominator of 6, I multiply the top and bottom by 3. So that's your shortcut. You could, if you want, follow the strategy I've been using, which is multiply this side by 6 and this side by 2 and so forth. You will still get an equivalent answer. For this one, I'm going to use the shortcut now to give you some exposure to that. Because if I multiply the top and bottom of only one fraction by 3, I'll get 6, a common denominator, like so. Because we got 3 times 1 is 3, 3 times 2 is 6. So you notice I got a common denominator. If you did it the long way, you'll get a common denominator of 12, and that's okay. Alright, so let's go ahead and combine these top fractions. So we got 1 minus 3. That's going to give me -2 all over 6. Divided by 3 minus 1, which is 2. That's where the 2 came from. On the top, I just added the 2 fractions, or combined the 2 fractions. Alright, I put a little note here. When I have a fraction divided by another fraction, put the 2 over 1. You're going to use the flip and multiply rule that we learned before. Put the 2 over 1, which is what I did. Now, and the flip and multiply rule is to take the bottom fraction, flip, and multiply across. That's right here. So you can multiply across to get -2 all over 12 and then reduce your fraction, or You can already cancel out these 2's right here. There's a 2 in the top, 2 in the bottom. You'll end up with negative 1 all over 6. And that would be your answer. So if you multiplied across, you would get negative 2 all over 12, which if you reduce is equivalent to negative 1 all over 6. So let's see, was that it? Yeah, that was it. So that was our last example. So we're going to get some practice on this. Let's see how you do on the task, and then we'll have some review activities on how to deal with these. Let me mention, example 4 is just harder because there's fractions involved. Now, if fractions is something you need to work on, then I would definitely like to see you in office hours because we got to know how to work with these fractions. All right, good luck on the task.